Thank you for coming to my talk. Thank you for coming to this stage. This stage, don't tell anybody, but this is the actual better stage. So come back and hang out over here later. You might see me around. My talk is going to be titled Full Stack Development in the Era of Serverless Computing. And I'm going to be doing something today that I've never actually done before. And I've been working pretty hard on an open source project for the last few months. And I think right here at the end of the day, or at the end of this talk, we're going to go ahead and release that. And we're going to go ahead and publish that live on stage. So I'm pretty excited about that. So my name is Nader Dabit. I'm a mobile and web developer. Really been specializing in cross-platform development for the last couple of years, mainly really focused with React Native. So if you've ever listened to React Native Radio, I hosted that podcast for a couple of years. I'm very active in the React Native community and more so kind of like pivoting now towards full stack development with cloud computing. But I'm still doing a lot in the cross-platform world. You can follow me on Twitter, dev.to, Medium, GitHub, everywhere on social media. I'm at Dabit3. So I've written a couple of books. The book that I've working on right now is called Full Stack Serverless. Touches on a lot of the topics that we're going to be covering today. It really focuses mainly on the combination of a client, a front end. It doesn't have to be React. I'm using React in the book, but it's kind of more around the building of full stack applications, leveraging the cloud, using some of the more modern tooling, using GraphQL, and in my book, I'm using AWS and AWS Amplify. The team that I work on is the AWS Client Technologies team. When people think of Amazon Web Services, they typically think of backends. They think of EC2 instances, storage. They don't really think of front-end development, but the entire team that I work on, we're always entirely focused on actually building for front-end developers. We talk to front-end developers, we are front-end developers, we live and breathe the front-end ecosystem. So everything that we do is really focused around improving the developer experience, and really what we're trying to do is kind of enable the next generation of developers to start leveraging the cloud, because in the past, I think cloud computing has been a little inaccessible because it's just really hard to get started unless you're already familiar with it. So, just on a personal note, something that's really served me well is being a futurist. And this may sound stupid, and you may think it's cool, whatever. But really, the idea of being a futurist is less about predicting the future, and I think it's more about listening to what's going on, observing the present, and really trying to see what's going to be happening over the next couple of years and being at the right place at the right time so you can ride these waves. When innovation happens, you want to be on the forefront of that innovation. So when the innovation starts cresting, you are in that arena already. Maybe you're specializing in that thing already, so you can kind of like gain the benefit from that and maybe reach back and help others as well. So the definition of my talk is kind of along these lines, and this is the answer, or the question I want to answer today is, what does full stack mean in the era of serverless computing? And we're going to look at why I use the word era in just a moment. And to start this off, I really like this quote from Bill Gates. I choose a lazy person to do a hard job because a lazy person will find an easy way to do it. I don't think he means lazy in the sense of sitting at home, sleeping late, watching SpongeBob, and not going to work. I think what he means is lazy in the sense that I'm not going to do something if someone else has already done it, or maybe I'm going to find some abstraction that makes this thing, the end goal, more easy to accomplish versus reinventing the wheel, or just being efficient with things in general, I think, is kind of, in my opinion, what he's saying there. And this kind of starts off in our world with abstractions. And there are two main parts of this talk, front end and back end. So let's look at the front end abstractions and see what's happened over the last couple of years. So if you're new into front end development, you may not have known this, but back in the day, you could actually get a pretty good job as a front end developer knowing the basics of HTML, CSS, and maybe jQuery. Maybe you didn't even know jQuery, you just knew JavaScript and you knew how to manipulate the DOM using JavaScript. And you could get by with not really much more knowledge than that. But today, it's not the same world that we live in, is it? And the complexity on the front end is gaining momentum, right? We're getting good abstractions, but as these abstractions come, people are introducing new problems to solve, and therefore we need to have ways to solve them. So therefore, people are going to build things for us to solve these problems, and therefore tooling and new things come out. So what we end up with is all of this stuff that we think that we need to know, and that we may need to know some of this stuff to get a job these days, right? So the complexity on the front end is moving much more faster to being more complex lately. And people, when they used to think of front-end developers, they used to think of front-end developers as kind of like not that serious developers, but now we're being taken more seriously because anyone kind of coming into this ecosystem must be taken seriously. And really the reasons I think a lot of this really comes down to are these main areas here. So single-page applications make us structure our applications in different ways. Our data is becoming more complex, and we're having to deal with a lot more data. Microservices make the fetching of data a little more complex. We're dealing with multiple targets. We don't really only want to ship to a single device these days. We have all of these new devices that we're working with. And then the user expectations that people get from being used to maybe using some of the more modern applications, you want your application to meet those needs. So you end up trying to have an application that kind of does all of these things and meets your users' expectations. So what are some of the abstractions that we're seeing that are kind of making this a little bit easier? There's a bunch out there, but what we're seeing, things like managed GraphQL, like Hasura and 8-base, styled components or emotion for CSS and JS, and it's kind of like a hybrid of CSS and JS. Next.js with Gatsby, React Native for cross-platform. So as things become more complex, we're seeing abstractions that kind of make these easier. Now, what about the backend? Who here is considers themselves a backend developer? Okay, so that's kind of what I assumed with this conference, because I'm a front-end developer. I assumed that this was a front-end conference, and that's kind of what that just told me. So let's talk about the backend, and this is just a quick overview of maybe a similar time frame of 10 years or 20 years or so. So a long time ago, when you built an application and you needed to host it somewhere, you may have had it on premises. You may have had your server in your home or in your office. If the internet went out or if there was a storm and the power went out, there was all these different variables that were up to the gods, I guess you could say that, to whether or not your application was going to stay up. And that was kind of where you were at that point. And then we had cloud computing that started coming along, and cloud computing could be mentioned as AWS and Microsoft and all these things, but it's also all these hosting services, right? Because you're kind of moving your infrastructure into these hosting services, and they're kind of taking care of most of the dealing with the scaling. I'm sorry, not the scaling, but dealing with the hardware and dealing with the hardware maintenance. And then we had serverless. So serverless has been kind of this new thing over the last 5 or so years, and we're going to dive pretty deep into this. And the main advantage that serverless brings to the table over cloud is that instead of having to not only deal with keeping your servers up and running and keeping everything working, you now also don't have to deal with scaling or patching or maintaining your servers at all. You're just given invocations, functions that you can run, and then once that function's done being run, you don't have to worry about dealing with it. You also don't have to worry about scaling this. So if you end up with 1 user or 1 million users, the serverless functions will scale for you. You're also starting to pay for computing time versus computing power. So when you're dealing with the basic cloud infrastructure, managing your own instances of EC2 maybe, you might be paying for that server regardless if someone's using it. When you start moving into the serverless paradigm, you're now paying for the actual usage. So this means you can start building a lot more things without spending a lot of money out of your pocket. Once you get users, then you start paying, which is a better problem to have. So what comes next after serverless? And this is what really interests me, because I think we're starting to see this happen already, and I don't really know what exactly it is. I'm just going to give you my opinion of what it is. So let's talk about the definition of what serverless is in a little more depth. What I really am interested in sometimes is these scientific and papers that come out from different colleges and all of these different really academic research done on serverless and cloud computing in general. A really interesting one that came out was Cloud Computing Simplified, a Berkeley view on serverless computing. And the gist of what this paper said is this: while cloud functions packaged as functions as a service offerings, so functions as a service would be serverless functions, while these represent the core of serverless computing, cloud platforms are also specialized also provide specialized serverless frameworks that cater to specific application requirements as backends as a service. So Basically what they're saying, put simply, serverless computing is equal to functions as a service and backends as a service. So this is a mutation of the old definition of serverless, where serverless used to mean serverless functions. Now they're starting to group other things into this paradigm. So what they're saying now is, okay, not only are we talking about serverless functions, we're talking about kind of managed services or backends as a service. So I went to the end of the paper and they have a predictions area. So these are the predictions that they have at the end of the paper. Pretty interesting. They think in the future you're going to see more backend as a service storage offerings. Serverless becomes simpler, even more simple than it is today. Serverless ultimately becomes cheaper than serverful, which is super interesting in my opinion, which would really change a lot of things in the world, I think, of what it is today. Serverful computing becomes less important relatively, which makes a lot of sense. But the most important point was that they came at the end was this: serverless computing becomes the default computing paradigm of the cloud era. So we're moving to where serverless is going to be the default versus something else being the default, which is pretty interesting to me. Another definition comes from Ben Kehoe, and instead of saying serverless is a thing, he says serverless is more of a spectrum or a variance. And Ben Kehoe is an engineering leader or manager at iRobot, and they make the Roomba robot, and he's running a serverless infrastructure there. And to be more serverless, he says that you have to be more serviceful, and I'll talk about what that means in just a moment, and using functions as a service, a tighter correspondence between resources used and resources built, again, going back to paying for compute time versus compute power, and then smaller and more abstracted control plane. So what does serviceful mean? So serviceful means this. This is kind of what I've put together based on some of the research that I've done. So what is a serviceful service? Serviceful service has no server operations, it scales seamlessly, no need to manage uptime, and variable expense versus fixed expense. So we're kind of inheriting these 4 properties from serverless, but we're adding a couple of new ones. We're also saying that a serviceful service, to be considered serviceful, also needs to be essentially codeless. So codeless in the sense that we don't have to deal with the code, not that there isn't any code running in the background, we're just interacting with these APIs. And then also, this service would assume responsibility for providing a defined set of services. So that means we're kind of taking what they're giving us and we're just using what they're offering. And these are a few examples. Auth0 is really great for managed authentication. Algolia is really great for search. Cloudinary for storage. You have recognition for machine learning and Netlify and AppSync. You have all these things coming out. There are hundreds or even thousands of these, right? And you're seeing more and more of these. So how does GraphQL fit into this? Because I think it really does play a very important role. Well, as the end goal of what I think is happening with all of this serverless computing is it's making everything more efficient. It's making us be able to build things quicker. Our developer velocity is moving faster. We're able to experiment more often and without as many drawbacks. So if we know that we're not going to pay for this actual computing power, we know that we can build something really quickly, and we know that it's not going to cost us a lot of money, why not try building this thing out in the next couple of days and just seeing if it works? Because our investment is continually going down. Even if this thing fails, we're able to at least try it out. So on that idea of developer velocity, I think GraphQL brings that developer velocity to the table as well. With building your own GraphQL server, though, you're losing some of that velocity because it's actually not easy to implement a GraphQL server with the proper authentication and authorization rules and all of the stuff that goes along with that, right? But anyway, so let's talk about GraphQL and why this is the case. So a typical microservice architecture might look something like this. You might be interacting directly with the microservice, or you might have some type of API gateway where you have that single API endpoint and you're interacting through that API gateway. With GraphQL, you have a similar end goal, right? But instead of just having all of these random, implementations of the API, you now have a unified way of interacting with that data. So no matter what happens after the request goes through, when you query data, you send that query from the client the exact same way. And regardless of the actual implementation details on the server, you're still going to be getting the data back the same way on the client. So you don't have to worry about any of the implementation details on the back end. You're given all of this also in a menu. So with GraphQL, you have introspection. You can see all of the different operations available. You can see all of the data that's available. You know exactly the data that's coming back. It makes for much better user experience once it's actually there, right? But getting there, I think, is the hard part. And that's another thing that I want to kind of talk about a little more. And this brings what I call schema-centric development. Unified data graph. The front end and back end end up being closer and more in sync. You end up having type safety throughout. You have simple access to data per client. So you can also be thinking about this in the sense that you're going to be needing the same data from your mobile device, from the desktop device, and maybe from your Apple Watch. But you don't want to be bringing the same data down on these different devices. You're going to need different types of data. GraphQL is perfect for that. Consistent API to microservices, Lambda functions, and databases. So you end up using GraphQL as an API gateway to all of these other microservices that are still there. You're not getting rid of them. You're just actually putting them in front of GraphQL. So full stack serverless. This is something that I really am interested in, and I think that I'm going to be giving you my spiel of what it is. So full stack serverless has the following characteristics. Heavy and intentional use of managed services. You choose a managed service because you don't want to rewrite something that someone else has done, right? So you have a feature, you first look to see if there's some type of managed service that can accomplish that goal. No, okay, next we go and we find and we build our own function that does the thing that we want it to do. Even better, if we have some custom client SDKs that make our API interactions easier. So we don't want to have a lot of custom code that we're creating to interact with all these different APIs. If you're using something like Apollo, for example, this kind of falls into that category, where we have this custom SDK for GraphQL, and we're able to use this for all of the different operations that we'd like to use. And then GraphQL as the main data source is an important part of this. So what are some assumptions and acknowledgements around full stack serverless? Well, you assume that code is a liability, and the least code that you can write, the better. So anytime that you can get away with not writing code, you do it. The front-end skill set continues to become increasingly valuable, and I think we're going to continue to see this in the future. We've already seen the skyrocketing value of front-end developers, the skyrocketing money that people are getting paid these days to be a front-end developer. I think that's not going to stop, and it's going to continue going up. Deliberate focus on not reinventing the wheel. So if someone else has done it, we're going to use what they've done to save our time, to save us some time. And with our increased value as developers, the least time that we spend doing something anyway, the better, because we're going to be saving time and therefore money. And then what really interests me is the definition of front-end, back-end, DevOps, full stack. All of this starts to blur because as a front-end developer, if you understand how to work with these APIs, you're able to do all of these things that these other people used to do, but you don't maybe need them anymore to do all of this other stuff. Maybe you still need them to do certain things, but for the most part, you don't need someone creating all of these CRUD APIs on the back end because you can spin those up with some type of managed database. You don't need someone to create your authentication on the back end because you're going to use an authentication service and all of these other things that kind of go into that. And then the DevOps part with serverless kind of goes away. So what are the benefits? Well, the benefits might be pretty straightforward. I may have gone over some of these already. But what we're seeing now is front-end developers that used to be labeled as front-end developers are now being called full-stack developers, or they're at least moving up the stack. They're able to do things that back-end developers only exclusively used to do. The developer velocity, developer efficiency starts increasing. You have decreased complexity because you have ultimately less code. More secure, more reliable, more scalable. Why would this be more secure and more reliable? Well, think about it. If you are a front-end developer and you want to create an authentication service and you've never done this before and you spend 3 weeks doing it, do you think you've done a better job than someone who's worked on an authentication service for 12 years or 5 years or even 2 years? That person and that team has iterated and solved all of these problems, unknown unknowns that you may not even know about. So of course, in my opinion, that's going to be more secure than spinning something up yourself. So how can we get into this? Well, I'm going to talk about some tools that are out there and kind of demo some stuff that I'm working on. So the combination of these 4 things equals full stack serverless. So a web and mobile framework or web or mobile framework, and you as a web or front-end developer utilize serverless functions, GraphQL, and managed services to build your applications. So what are some tools out there? So for managed services, Auth0, Cloudinary, Algolia, Netlify, serverless GraphQL, more options coming out. 8base recently came out, really nice. Hasura Cosmos DB has an adapter, and AppSync is what we work on. Serverless functions, Netlify now. Do I even have to go into this list? There are dozens of them out there. In fact, every week or every month I see a new provider coming out with a abstraction over serverless functions. Now, what do I work on? The team that I work on, we're building a framework especially for this. So we call this AWS Amplify, has the 4 things that I have listed here. We have a command line that creates managed services. We have a client that connects to the services. We have hosting provider for CI and CD, and then we have a tool chain for doing things like GraphQL code gen. What are some of the things that you can do? Well, authentication, GraphQL APIs, serverless functions and APIs, storage, AI, machine learning, hosting, AR and VR. I have a bunch of stuff not listed here, but you can go check it out on our website. We also have framework-specific components for all of the major front-end libraries, React, React Native, Vue, Angular, Ionic. And what's my favorite thing about what we're working on is this GraphQL transform library. And this is essentially an SDL over regular GraphQL schema that allows you to decorate your schema and add additional features. And what these features, and what ends up happening under the hood is we create those resolvers for you, and then you can then modify your resolvers with your own business logic. So if you need a database, schema, subscriptions, resolvers for a CRUD app, and you want to make it a to-do app, instead of writing create, read, update, delete to-do operations, the resolvers, the database, having all that created, you can just create a to-do type, decorate it with the at model. We'll deploy the database. We'll create all that schema. You can then just modify that to work on your app. We have all these other ones, auth for adding authorization rules, connection for adding data relationships, one-to-many, many-to-many, all of this other stuff as well. So what about a serverless, for the serverless backends? Yeah, I think this is basically the stuff I kind of went over already. What you end up with when you use the GraphQL transform, you have authorization rules on your API. You end up with your database and all of this other stuff. And to get started with this, you just run Amplify init, Amplify add auth, and then you choose GraphQL and you're kind of ready to go. Now for the demos. So what I want to demo first is, I want to show you, can we build a conference app for ReactiveConf in the next 2 minutes? Yeah, 2 minutes, why not? So what I created was conference app in a box, and this is an implementation of full stack serverless. What we have here is the React Native app that you get out of the box once you create a, let me go ahead and see if I can refresh this. All right, there we go. So conference app in the box, yeah, I created this open source project. If you want to create a conference app, you clone it, run Amplify init, and then you can populate the database. So this is what the boilerplate comes out to. Let's create the app for this conference. So what I want to do is first go ahead and open up some text editor. And what we're going to do is I'm going to go ahead and get the information that we're going to need for this conference. So first of all, we need to get some conference speakers. So what I want to do is populate the database. So to do that, I'm going to go into the Amplify console. And what we're going to do is create a couple of talks. So the first talk I'm going to create is going to be, I guess, this talk. And then I'll go ahead and create this talk here. All right, I think 2 talks is enough. Let's go ahead and refresh. All right, we see that we have our speakers there populated. We can drill down. We can see the information that we populated this with. Next, let's go ahead and theme this because this doesn't really look like the ReactiveConf color scheme. So what we want to do is set a base primary and light primary colors. So I'm going to go into the theme. I'll go ahead and update that. I'll update the highlight color. And what we're going to do is then update the logo. Over, yeah. Okay, cool, thanks. What we're going to do for the logo is we're going to use this reactive logo. So let's go ahead and refresh that. And now we have a ReactiveConf app. Well, that looks very similar, actually, because the color scheme is similar. But now you see we have green. Let's go ahead and add a comment, though, because maybe we want to troll somebody and tell them that their talk is not good. So what you can do is you can create a comment, and this will be done through GraphQL subscriptions. So it will come through in real time. So let's go ahead and list talks first. And we get the talk ID for the talk we want to create a comment for. So now we'll go ahead and get the mutation for creating a comment. And I'll take this talk ID and I'll put it here. And there you see that the talk came in real time. We have our comments coming through. All of this was deployed within about 5 minutes using the full stack front end and back end. So that's one thing I'm working on. The next thing I want to show off is something that I am releasing today. So this is the Jamstack CMS. And I'm going to go ahead and pull my slide deck back up so I can kind of give you an overview. As you can see, I speak at a bunch of conferences. So where were we? Oh yeah, so conference app in a box. So one last thing. I've worked with over 30 conferences with that. It's only been out for about 6 months. I've worked with 3 independent consultants that have sold their app, reskinned it for $50,000 total, and the average hourly rate was $1,500 because all they did was like download this app and resell it for like $15,000 to $20,000. Pretty cool. So based on my pricing, the 30 conferences that I've worked with, it's around $500,000 in value that people have gotten from it so far, and it's completely free and open source. And then today I'm introducing this, the Jamstack CMS. Jamstack CMS is a full stack CMS built with Gatsby on the front end. It's built with serverless technologies on the back end. And you can deploy to any hosting provider, Netlify, Amplify console with a single click using webhooks. This is kind of an overview of what it looks like. And let's go ahead and kind of take a look at how it works real quick. So this is kind of a running version of a full stack CMS thing that I've deployed recently. This is essentially, in my opinion, it's like a modern version of WordPress, because when you think of WordPress, WordPress has the database, the authentication, the front end, everything all kind of bundled into one. This is the same thing, but kind of built with modern technologies. You can create posts, you can create pages. In the admin panel, you can kind of see all the posts that you've created. You can unpublish directly from the admin panel. You can create a new post using the WYSIWYG editor. You can actually create new web pages as well. And once you have figured out where you want everything to go, you just go ahead and click save or publish, and it will go ahead and publish. There's also a settings where you can change the theme that you'd like to be working with. So maybe we want to have this ReactiveConf theme. We can set that. And then once we're ready to kick off a new build, we can actually just click deploy. And this will deploy a new version of our app into our hosting provider. And for me, I'm using Amplify console. So if I go here, look at Jamstack CMS, I give this a second. I come back, and it's still not building yet. But there we go. So now we see that we've kicked off a new build. We did that directly from the front end. The thing that's happening is we're building and deploying those static assets. So when people access this site and they're not an admin, they just see the blog. Okay, so that's it. I'm sure I'm a little bit over on time. We'll go ahead and wrap this up. If you want to follow Jamstack CMS, oh, you know what? I said I was going to release this live on stage. Let's go ahead and do that. So I'm going to go to settings and my GitHub repo. Jamstack CMS, make public. First time I've ever done that. So go, if you're watching this, go star this and like brag about it and all that stuff and tell all your friends. Okay, cool. Yeah, so thank you for listening to my talk. I'm going to skip my last few slides, but thank you for listening to my talk.